This diagram will help to understand how the demand is calculated and is input into the supply chain operator. First, we have to identify the three types of demand which are being used in the project. The first is the enriched demand by the sales force. This will be represented by the sales manager enrich forecast. This is done by the sales force, account managers and sales managers, and is used to drive the demand for commercial customers. At the same time, commercial customers can be subject to a committed volume demand, which is entered by the marketing manager. Negative free-pot development will take care of making those two demands align. There's a third demand that works only for captive customers, which is the captive volume, and that will be handled separately. It is entered by the planner group, and it's assigned to a specific location, just the same as the committed volume is also assigned to a specific location. Okay. Those demands will flow to the consensus demand key figure, which is the input of the demand to the supply chain operator. Also, the committed volume and the captive volume will flow into the minimum constraint demand key figure. In that way, those two demands can be assigned the highest priority when the supply calculations are done by the optimizer or even the heuristic. Let's work with an example to illustrate how this works. Let's say, for instance, we start with a committed volume of 10 for the first customer product combination, 5 for the second. For those two same combinations, we could have an enriched value of 9 and 8. Okay. Negative free-pot development can make an arrangement between those two key figures into the calculated demand key figure, just to make sure they are correctly aligned. The results in the calculated demand key figure made by the negative free-pot will be such as 10 and 7. In that way, the calculation of the calculated demand will make sure that no combinations have a higher committed volume than an eventual consensus demand value. So after this, these values will be copied over to the following key figures using the same values calculated in the negative free-pot. And this will be entered to the optimizer. At the same time, the committed volume will be copied to the minimum constraint demand key figure using the same original values. This will guarantee that the committed volume gets the highest priority in the supply chain calculations. At the same time, another key figure is being calculated. This key figure is the free-pot. The free-pot is not an input to the supply chain operator, but it is very helpful since it allows the planner to see which is the difference between the total demand represented by the consensus demand and the committed volume. Those values will be then stored in the free-pot key figure and will help the planner make decisions on how to handle the demand even before it is fed to the supply chain operator. In this case, the value of the free pot will be 0 for the first combination since the consensus demand is equal to the committed volume. But for the second combination, the free pot will get the value of 2 since consensus demand is 7 and the committed volume is 5. Now, this free pot demand is the part of the demand that can be easily moved by the optimizer to other plants or eventually can be dropped from the plant if the capacity is not enough to cover all the demands. Now let's do another example with a different situation. Let's say the committed volume is 10 and 5, like in the previous example, but in this case, the enriched value is 9 and 4. This represents that if you aggregate the values for committed volume and sales manager enriched forecast, the committed volume is all the way higher on an aggregated basis than the enriched value. Then the negative free pot can only go as far as balancing the most possible combinations, which will be 10 for the first combination, and at the end, for the second combination will be a value of 3. Again, this will be fed to the other key figures using those same values. Now, the results in the free pot will be, for the first combination, the free pot will have a value of 0, since the consensus demand and the committed volume are the same, 10. But for the second combination will be also 0. Even if a negative value will be calculated by the first instance, the calculation set up in the IBP will make sure that the free pot is shown as 0 in order to avoid confusion for the planners. However, in the minimum constraint demand key figure, the complete values from the committed volume will be entered in IBP. In that way, we still can make sure that the supply plan will consider the highest priority for the committed volume, and that will be explained in a separate recording. Now, we can also give an example of how the captive volume is going to work. Captive volume will be entered just for captive customers and assigned to a specific location since it is entered. These values will be copied via a copy operator to the adjusted unconstrained sales forecast key figure, and from there they will flow to the consensus demand key figure in order to be considered by the supply chain operator. The captive volume figures are also going to be copied into the minimum constraint demand, so they get the higher priority they require. For captive customer combinations, the free pot will always be 0 because the captive volume is driving the consensus demand. Then there is not going to be any difference that can be captured in the free pot. That's always going to be 0 and 0. As an important remark, uh, it has to be highlighted that the captive and committed volume are moved to the minimum constraint demand also via a copy operator. This is not a calculation carried out with the calc engine in IBP. It's a copy operator. It is important to mention that all these calculations regarding negative free pot, uh, free pot itself, this all can be seen in the base version without the need to copy the information to other versions in the supply plan operator.